Hello everyone, welcome back to our series of lecture for the course Probability and Statistics. We have solved a few examples in some other lecture. We are going to have few more in this lecture. Okay, look at this exercise problem. A discrete random variable y has the probability mass function. So the mass function of y is given. Now determine the cumulative distribution function of y. So you have to find the cumulative distribution function. So if you remember, our cumulative distribution function definition is what? So we denote it by usually by the capital F of y. And what is that? It is the probability of y is less than or equal to small y. Whereas PMF is what? Probability mass function is capital Y equal to y. Probability of capital Y equal to y. And cumulative distribution function is probability of capital Y less than or equal to y. And it means just you have to take all the values, sum of all the values up to y. So P of k, where k is up to the value y. Right? Now look at the probability mass function. So therefore, the random variable y take the values 0, 1, 2, and 3, like this, 3 points. So we can find the CDF step by step. So case by case. So maybe the first case is take the value where y is less than 0. Right, so up to point 0 it is starting, right? Y is taking the value 0, 1, 2, 3, 4, 2, 3. So take the value before zeros, y value. Then what will happen? In this case, fy means what? F of y means p of y must be less than or equal to this y value, and it is not having y is whenever y is equal to y value is between 0 is less than 0. Maybe I'll write it the small y only, but y is less than 0, but there is no such p0 whose value is positive, so therefore this value is 0. Clear? Now next is take the value between 0 and 1. So whenever 1 between 0 and 1, so take the value of from 0 onwards, 0 less or equal to y less than 1. If your y value is such that, then what will happen? So in this case, f of y can be, so y value is between 0 and 1, right? So and you have to take all such p value, probability mass function values, you have to take the addition of it. So only one value is possible when the 0 is there, and between 0 to 1 there is no other value, right? And it is not taking the value 1 even. So from 0 to 1 you have only one value, which is p of 0. So f of, in this case, f of y is equal to basically p of 0, and which is 0.1. Now what is the next one? Next step is take y less or equal to y less than 2. If your y value is between them, then what will happen? Your f of y should be, now y is between 1 and 2. Maybe y value is, suppose you think 1.5. So you have to take the probability mass function addition up to 1.5. So what are the values possible in this case? It is p of 0 and p of 1. You have to take only up to 1, because there is no other value, and 2 is also not included. So p of 0 plus p of 1. And what is this value? It is 0.1 plus 0.3, which gives you 0.4. Clear? The next one is whenever 2 less or equal to y less than, maybe you can think of it 3, the same way. So what is f of y value in this case? Again, we can take the values p of 0 plus p of 1 plus p of 2. And this value is 0.1 plus 0.3, and p of 2 is 0.4, which gives you 0.8. right? And the last one, which is whenever you have y is greater than or equal to 3. So y value is greater than or equal to 3. That means suppose y equal to 4. Then you have to take fy, means you have to take all the probabilities up to 4, addition of all. So what are the things are possible in this case? 0, 1, 2, 3, all cases are possible. So it is basically p of 0 plus p of 1 plus p of 2 plus p of 3. Now up to these three values, the value is 0.8 and p of 3 value is 0.2. So this value is 1. Yes, it should be, right? So finally we got the probability, like we got the cumulative distribution function, which is actually the piecewise defined function. So f of y is equal to, what are the values we got? It is 0 whenever you have y is less than 0. It is equal to 1, 0.1 if you have 0 less or equal to y less than 1. This value is 0.4 if you have 1 less or equal to y less than 2. This value is 0.8 whenever 2 is less or equal to y less than 3. And this value is 1 whenever we have y is greater than or equal to 3. So this is the cumulative distribution function for the given random variable. So this is an example where we have done that probability mass function is given and you find its cumulative distribution function. Clear? Okay. Let me move to the next question. Look at that. This is again a similar type questions only, that your probability mass function is given and you have to find the cumulative distribution function for the random variable w. So I hope you can easily do. So only thing is that let me give you just hint. You can check mostly for this function the answer will be this one. So you can just check and you can check whether you are getting this value or not. So it is 0 whenever w is less than 1. It is 1 by 10 whenever 1. Okay, just a minute. It is removed. So f of w is equal to, you can just do your own. I hope you can do it the same way, the way we did. Whenever w is, okay, here w is taking the value 1, 2, 3. Now. So whenever w is less than 1. And it is 1 by 10 whenever 1 is less than or equal to w less than 2. It is 2 by 10. No, sorry, it is 3 by 10. Okay. 3, okay, 1 by, yes, 3 by 10. Whenever you have 2 is less or equal to w less than 3. And it is 6 by 10 whenever you have 3 less or equal to w less than 4. And finally it is 1 whenever w is greater than or equal to 4. So you check whether you are getting this is as a cumulative distribution function of the given random variable w1. So you do it by your own, the same way we can do. Okay, I want to discuss a new type of problem. Yes. So in the previous two examples, we have seen that the probability mass function was given and you had to find the cumulative distribution function. Whereas this question is the cumulative distribution function is given. So the cumulative distribution function of W is given. Find the probability mass function of W. So it is a CDF is given, you have to find the PMF. Now if you remember in our lecture what we have done, we have understood that how to find the probability mass function, right? So here this CDF is given. So we have seen that the probability mass function W is obtained by finding the difference in the CTF at the jump point. Now what are the jump points? It is -2, 0, then 2. These are the jump point. So whatever was the height, that jump, that will give you the probability mass function, right? So if you remember, then random variable basically takes the value. The first question answer is random variable W will takes the value at the jump point, which is -2, then 0 and 2. And all other values it is 0. Right? Now what is the probability mass function? P of W is equal to -2, which is small p of -2. What is this value? Now this is the that how much height jump it is there. If you look it in our theory part we have seen, right? So it will be f of -2 minus any of its value, the below one, right? So maybe you can take that f of -3 or something. So f of -2 is what? It is 1 by 3. F of -3 is 0. So this jump height is 1 by 3. So at the point -2, it is 1 by 3. So we got the P of W equal to -2, it is 1 by 3. Similarly, P of W is equal to 0 is what? It is small p of 0, and it is what? Again, from 0 to the previous point -2, what is the jump? So it is f of 0 minus f of -2. But what is f of 0? F of 0 it is given as 2 by 3. F of -2 it is 1 by 3. So this value is again 1 by 3. Then the next one, P of W is equal to 2. So it's same way we can do. So f of 2 minus f of 0, the jump height, how much height it is getting, it is jump. So f of 2 is what? It was 1 minus f of 0 is 2 by 3. So again it is 1 by 3. So we got easily all the values of the probability mass function it is. So the PMF, probability mass function of W, is small p of W is equal to 1 by 3 whenever you have W equal to -2 is equal to 1 by 3, whenever you have W equal to 0 is equal to 1 by 3, whenever W is equal to 2. And for all other value, it is 0 otherwise. So this is the probability mass function. Clear? So here it was given that the CDF, cumulative distribution function, and we find its probability mass function. And we are done. And then after that, the other problems are very easy. What was the second one? Compute P of W is less than 1. Compute P of W greater than -1. And compute P of -1 less than W less or equal to 2.5. So all these things are very easy. So the part B is P of W is less than 1. That means what? Up to 1, not exactly the point 1, up to 1, what are the points you have? Right? So it is P of maybe one should take, you have only the -2 and 0 and 2, right? So up to 1, like very close to 1, but not exactly the point 1. It is the value small p of -2 plus small p of 0. Both the value it can take. Correct? Small p of -2. So it is 1 by 3 plus 1 by 3. It is 2 by 3. Now the part C is P of W is greater than 1. You have to calculate P of W is greater than -1. Now how to do that? Again, it's an easy one. So we know that probability mass function whole sum is 1. So we can do it. It is 1 minus P of W is less than or equal to -1. Right? Now that means 1 minus W is less than or equal to -1. So up to -1, what are the values of P we have? It is only P of -2 because 0 is not included. So it is P of -2. And this value is 1 minus 1 by 3. So this value is actually 2 by 3. Clear? And the next question was question number D. It is P of minus 1 less than W less than or equal to 2.5. Now this one has a formula, we all know. It is, we can say it as f of 2.5 minus f of minus 1. And what is f of 2.5? Or you should take the values at minus 1 to 2.5. So minus 1 is W value is greater than minus 1 and up to 2.5. So both the way one can do. So it is f of 2.5 what was given now, that this value was given f of W value. 2.5 means what? More than 2. So 1 minus f of minus 1, we have we can also see that probability up to minus 1. So it was it will be 0 only. It will take the value up to minus 2 only. So it is 1 by 3. So you can do it in this way, which value is 2 by 3. Or you can do the same thing, that W value is between minus 1 to 2.5. So then W, what are these W value are there? Minus 1 to 2.5. The value can be 0 and the value can be 2 also, right? So that means it is P of 0 plus P of 2. Both ways it is possible, and this means 1 by 3 plus 1 by 3. It is 2 by 3. In both the way one can do this, right? So this is again an easy problem, but you look into that cumulative distribution function is given, find the PMF. Previous problems are PMF was given, find the CDF, right? And after that, these are just a simple thing, B, C, and D. So the same way one can solve this problem, question number 9th one, right? So I'm not going to give you the solutions. It is your job. Just do it in the same way and check with some of your friends whether your answer is correct or not. Okay. Okay. We'll come back in the next video. Thank you very much.